So today we're going to be continuing with topic 2.6, inverse functions. I think my examples got a little out of order of this box. So we're going to start actually with this box right here. So we're going to consider the function f of x equals x squared. And we're going to compare it, complete the following table of values for f of x. So we actually talked about this yesterday, that basically the whole thing with inverses is that we switch x and y. So I'm going to basically switch the values on the table. So with values on this other table. So I'm going to flip-flop 4 and -2, 1 and -1, 0 and 0, 1 and 1, 4 and 2. But we're going to talk about whether or not the new table is actually a function, which I know we haven't talked about that yet. So in order for something to be a function, you can only have one y value for each individual x value. And you'll notice that in the second table, my x value of 4 has two different y values, which makes it so that it is not a function. So we would call this that it's a relation, not a function. So the way that we would say this is that notice that the second table does not represent a function, since inputs have more than one output. So the function f of x equals x squared does not have an inverse that is a function. And that's okay. So really what it's meaning is that we have, if I originally have this, and we can do what we call the vertical line test, and we know that by using a vertical line on it, that it is a function because the vertical line only crosses once. Well, the inverse picture of x squared looks like this, and you'll notice that a vertical line, it fails the vertical line test because it crosses more than one time. So let's go ahead and look at example 11 and 12, and then we'll come back to the other boxes there. So in example 11, I really should have had a second table in there. They only gave we only get the table for the inverse, and we really need the table for the original as well. So that's our whole work is going to be the table. So f of x, and I'm going to pick some values. In fact, I have the wrong values apparently in this table right here. So I'm actually going to use the values -4, -2, 2, and 3, and we're just going to redo these values in here. So I'm going to try to read the y value off of the graph here. So I'm going to go to -4, 1, 2, 3, 4. And I'm going to read the y value, or the y value off the graph, which looks like +4. Then I'm going to go to -2. I'm going to read the value off the graph. It looks like 2. And then I'm going to go to 2. And I'm going to read the value off the graph, which looks like -4. And then I'm going to go to 3. And I'm going to read the value off the graph, which looks like I'm looking at the wrong one. It looks like it's probably at 1, 2, 3, 4, 5. Looks like it almost goes beyond. It might be at -6, so that's probably not our best choice. So I'm going to try to grab something that's a little bit more in here. In fact, I'm going to kind of look at that 1.5 because so it looks like 1.5 is at -1.5. So I'm going to use those values, and I'm going to swap them for my inverse. So my inverse would be 4, -4. 2, -2, -4, 2, -6, 3, and -1.5, 1.5. I'm going to erase on here because I don't need all that mess anymore. And I'm going to go ahead and plot those points. So I'm going to go out 4, down 4, maybe. I'm going to go out 2, down 2. I go out -4 and up 2. I'm going to go out -6 and up 3, so something like that. And I'm going to go out -1.5 and up 1.5. Now, mine never turns out to look like it's supposed to, but it's supposed to be something along these lines. So it should, in theory, reflect across that y equals x line. All right, let's try it again. So this time I'm going to use again these values from the table here over here in my original table. So I'm going to go -4, 2, -2, 2, and 3, just to start. Okay, so we're going to go -4, 1, 2, 3, 4, and we're going to read the y value off the graph. 1, 2, 3, 4, -4 again. I'm going to go -2, and I'm going to read the y value off the graph. Looks like we're still at -4. I am going to go out 2, and it looks like we are at 0 for the y. I'm going to go out 3. It looks like we're at about 1/2. I might want one more. I'm going to go to 4 just to check. So when I'm out 4, it looks like I'm up at 1. All right, so I'm going to swap my x's and my y's. So I've got -4, -4, -4, -2, 0, 2, 1/2, 3, and 1, 4. I could probably eliminate the 1/2 3 point if I wanted to. All right, so let's go ahead and plot this. So I'm going to go out -4, down -4. We're going to go out -4 and down -2. We're going to go out 0 and up 2. We're going to go out 3 and up only 1/2. I'm sorry, I messed that up. We're going to go out 1/2 and up 3. And then we're going to go out 1 and up 4. So it should look like that. And that one's much more distinct. We can actually see that line folding on the line of symmetry there.